Hello, welcome to my channel Deep Learning Biology. My name is Dr. Vikas Mardwaj. Within this video, I am going to teach you about enzymes. So, in this video, we are going to discuss what is apoenzyme, what is holoenzyme, what is cofactor, what is, one minute please, coenzyme, and finally we are going to discuss what is prosthetic group. Okay, so all these terms we are going to discuss in this video. Now here I just want to tell you, you must be knowing enzymes, generally they are proteinous in nature. So let's suppose this is one enzyme. Okay, now here you can see the active site. Okay, within the enzyme you are going to have a pocket that is known as active site. At the active site, the substrate, it will come and bind, and from here what we are going to see, the release of the product. Okay, so here you see this one, this is your complete enzyme. Okay, now any complete enzyme, if you are going to see, it is also going to have some additional component. Okay, so here the additional component, okay, it is known as cofactor. Okay, so now here you can see the complete enzyme, it is made up of two components. One is the proteinase part, that is known as apoenzyme. Okay, so here apoenzyme plus cofactor, apoenzyme plus cofactor, it is going to make the complete enzyme, that is holoenzyme. Now try to see here that within the enzyme we are going to have this part. Okay, this part, okay, this is known as apoenzyme. Okay, and this additional factor, it is known as cofactor. Okay, apoenzyme plus cofactor, it is going to make complete enzyme, that is known as holoenzyme. So hopefully it is clear to you what is holoenzyme. Now here you can say that holoenzyme minus cofactor, it is the apoenzyme. Now let us focus on this term cofactor. I have told you that generally the cofactor, it is non-proteinous part of the enzyme. Okay, while you see the apoenzyme, it is the protein part. Okay, now here if you see in the case of cofactor, we are also going to have categories. Now these cofactor can be of two types. Okay, one, the cofactor can be inorganic ions. Now here these inorganic ions, they are going to help enzyme, and here some of the cofactors which can be present with the enzyme, it can be Fe2 plus, magnesium ions, okay, manganese ions, okay, zinc ions. Now here if you see some of the cofactors, the inorganic ions which are generally present, which are present with the enzymes, for example copper ions, okay, they are present in cytochrome oxidase. Okay, same way ferric ions, okay, they are present in enzymes like catalase, peroxidase. Okay, even in the case of cytochrome oxidase. Okay, now same way the inorganic ions like potassium ions, they are present in pyruvate kinase. Okay, same way you are going to have magnesium ions, they are present in hexokinase. Okay, or you can say glucose 6 phosphatase. So here hopefully it is clear to you that the cofactor, okay, which are the additional component within the enzyme, okay, and generally these are non-proteinase part. It can be inorganic ions. So here I have given you some of the examples of the cofactors which are going to act like inorganic ions. Now here I have told you the cofactor, they can be of two types. One is inorganic ions, another can be organic, or you can say metallo-organic component. Okay. Now here, if the cofactor is organic, what is going to happen? This is known as coenzyme. Now keep in mind, generally the organic component, it is loosely bound. So coenzyme, it is loosely bound with the enzyme. Okay, so hopefully it is clear to you what is coenzyme. Now here I just want to tell you that generally these coenzyme, they are being derived from organic component like vitamins. Okay, so hopefully it is clear to you what is cofactor. Cofactor, they can be of two types: inorganic ions, organic, or metallo-organic. Okay, organic component conjugated with some metal, and here keep in mind the organic component, it is known as the coenzyme, and it is loosely bound. Now here at the last I just want to tell you what is prosthetic group. Okay, now keep in mind tightly bound or covalently bound, tightly bound or covalently bound cofactor, tightly bound or covalently bound cofactor is known as prosthetic group. Okay, so here you see in the case of coenzyme, what you are going to see, coenzyme is loosely bound. Okay, so here I just want to tell you the example of, you must see NAD+. Okay, so nicotinamide adenine dinucleotide, okay, it is going to act like coenzyme. Okay, same way here if you see the prosthetic group, it is tightly bound or covalently bound cofactor. Here I just want to give you one example, not of the enzyme but of the protein, hemoglobin. Okay, remember in the case of hemoglobin, heme. Okay, hopefully you remember the structure of hemoglobin. In the case of hemoglobin, heme, it is tightly bound and it is going to act like prosthetic group. Okay, hopefully it is clear to you what is here we have discussed what is holoenzyme. Okay, the complete enzyme is known as holoenzyme. What is cofactor, what is apoenzyme, and here I have told you cofactor can be of two types: inorganic ions or the organic or metal-organic component, and we have discussed what is coenzyme, and here we have also discussed what is prosthetic group. Hopefully all the points are clear to you. Thank you for watching this. Please do like, share the video and subscribe to my channel Deep Learning Biology. Okay, thank you.